think I did it. I'm going to require some kind of confirmation, some kind of external confirmation that I exist. Everything's different. And I'm using a green screen, although it's not actually a green screen. I'm using Zoom with its magical background. So I am actually in the back of our trailer. It's this tiny little space, sitting in a camp chair with my computer, my streaming computer packed in all around me. But it seems to work. The audio's a little hollow, I think. But yeah, we got it going. So yeah, I hope you all had a good summer. I sure did. I mostly have been gardening. As I think we mentioned right at the end of the last season, Carl and I sold the house. The kids have moved out. So my son has his own apartment now with his girlfriend. My daughter is at university, so we're empty nesters now. And so we bought a property just outside of town of the city that we live in. And we it all sort of, relied on us being able to get Starlink. So I'm actually broadcasting this stream from Starlink. So you're going to have to let me know if there's any problem with the audio video, if there's any hiccups, whatever. But so far, I'm looking at the stream. It all looks like it's going great. So yeah. So I'm spending almost all my time outdoors at this point. Mostly, I bought a chainsaw. And I've been sort of cleaning up all of the dead trees that are on the property. I've been gardening like crazy. It's been good. Mostly just spending my time, walking in the forest, watching nature, and just working on the property. So, but it is good. I definitely missed, and of course I have been working on Universe Today. Even though we call it the hiatus, it's just the hiatus from live streaming. So behind the scenes, I'm still running the whole show at Universe Today, coordinating with all the writers. Chad and I have been working on a lot of the back end tools that we use for running the show. So he hasn't been editing video, but he has been programming his little heart out. So we've been doing a lot of that. But yeah, it's all been really good. You see the sunburn? Well, who knows? Is it sunburn? Is it just my natural ruddy complexion? You never can really tell. Well, maybe, I don't know. Maybe there is this bit of a tan / burn going on there. I put on sunblock, but still, I'm out in the sun a lot right now because, the weather just turns. It's been beautiful so far, but the weather will turn on us and then, it's all going to go horribly, horribly wrong. Me with a chainsaw. You need a channel for that. Yeah. I'm still writing the newsletter. So really the only thing that I haven't been doing is all of the live streams. And we knew that moving up here was going to cause an enormous disturbance in how we organize everything, all of the gear. But I'm kind of impressed. It took me a couple of hours to get everything set up and working, and it seems to be going. So yeah, right on. Okay. So, let's see. So what do we got today? So we're going to do a question show. I've got a bunch of questions prepared. We're going to go into any questions that you guys have as well. And then, and this is just an experiment. Like, it's entirely possible this show will never see the light of day. And the real first episode is going to be, next week. Who knows? Who could say? Now, I've got a couple of announcements to make quickly. I've got an interview coming up on Wednesday morning. So that's going to be the first interview. And then I've got an interview coming up next week. And I completely forgot what the one tomorrow is, but it's super cool. Yeah. All right. Let me see if I can find my explanation. So a guy named Marcus Jansen from Sweden, and that's when I'm telling you now because that's Wednesday morning. Let's see. Yeah, okay. So, right. So, Wednesday's interview, we're going to be talking. This is kind of cool. So, it's a researcher. He's proposed using a star shade, that crazy flower shaped occulter that would be used with space telescopes like James Webb and stuff. They're proposing that you could actually use that technology with ground-based telescopes. So you don't actually need a space-based telescope. You could launch a star shade and use them from some of the big next-generation telescopes that are coming up and use them to find exoplanets even better, which is really cool. And then the one that I'm doing the week after that is going to be talking about cosmic dawn, which is this time period after the cosmic microwave background radiation, but before the formation of the first galaxies. And most of the big unsolved mysteries in cosmology are located in that area. When did the first stars come on? How did the first supermassive black holes form? How did we get from the initial cosmic microwave background to the large scale structures that we see in the universe? And so we're going to be having that conversation next week. But I'm queuing up a whole bunch of interviews as well, and we'll see how well that works from the trailer. I have to add a few other pieces to the puzzle to go from there. Okay, so let's record. Here you go, Chad. That work? Yes, I'm recording. Okay, and I'll record the audio. All right. The audio is recording. All right, let's get started. I don't know where to look anymore. Okay. Hey, everyone. Welcome back to the Question Show, the new season. Of course, I am recording this episode from my trailer on my new property. I'm no longer living in the house and no longer having the old studio that I did. We're building a brand new studio, but we're about 4 months away from being able to move into the studio. So until then, I'm going to be recording these episodes from my trailer. But enough of that. Let's get on to the question show. As always, your questions, my answers. If a question pops into your brain anywhere across my channel, just write it down. I'll gather them up and I will answer them here. All right, let's get into it. So, Chad, I realize we've got a problem, which is the background on the camera doesn't have the zoom background. So you're probably just going to have to rip the video from the YouTube video, even though it's going to be kind of lower quality. But I can't think of a way that we can get around this. For 4 months, people will survive but we'll have the better audio still. Okay. Yes, I am recording. Okay. Joyful running. Hey, Fraser. Hope your hiatus was wonderful. I have a question for the next question show. I went out and watched the Perseid meteors last month, and I saw a really bright one that arced through about 40% of the sky, creating a green glow around the main streak of light, and even made a faint noise, a sizzly whoosh. Is there a way to estimate how big the meteor was based on how long the streak of light is, or any other factors? So what you saw is called a fireball or a bolide, and they're very rare. I've only seen one in my life, and I don't even know if it was as spectacular as the one that you saw. And in general, I mean, astronomers have fairly mushy terms about this, but in general, a bolide is any meteor that is brighter than about magnitude -4, but brighter than Venus. Although they can be brighter than Venus, they can be brighter than the full moon. And when they go off, when you're out there watching the meteors, and you see these tiny little streaks, and then every now and then you see the bolide go off, and it brightens the landscape. It's almost like it briefly turns things into daytime. It can get so bright. And like I said, they're very rare. A lot of the people who spend a lot of time out there, they see maybe a couple of a year, maybe one every few years. I've seen one. One of the other cool things about them as well is, as you said, they make a sound. They can make a sound. And so there's two kinds of sounds that these bolides can make. The one is you're getting an actual shock wave. As the meteor is entering the Earth's atmosphere, it is going faster than the speed of sound, and it is causing a shockwave like an aircraft. That's generally for the biggest ones. And of course, when you think about some of the most dangerous bolides, like the Chelyabinsk one, the shockwave was so powerful, it blew out the windows in the nearby city. The other sound that people have heard, and this is more like, as you said, like a sizzling, a whooshing, a crackling, and actually astronomers aren't entirely sure what that is. They think it has something to do with some kind of interaction with the atmosphere, some kind of very high frequency sound. But they haven't been able to track it down, and they don't really know what causes it. But a lot of people have said they've heard it, so people are pretty certain that it does actually exist. I didn't hear one on the one that I saw. Now, the question you asked was about the size. So when there's a meteor shower and you're out there watching and you're seeing these tiny little specks, they are very small. In general, a meteor is like the size of a grain of sand. They can be smaller, they can be a little bit bigger, and the bigger they are, the longer they take to burn up and the longer the trail they do. But the biggest fireball, as I said, Chelyabinsk, you could have ones that are the size of, say, a car or a house, and it's anywhere in between. So you could have ones that are the size of your fist. You could have ones that are the size of a refrigerator. You could have ones that are the size of a car. And the bigger they are, the longer the trail they leave, the brighter they get as they come into the atmosphere, and the higher chance you're going to get some kind of audible sound. And in some cases, they are able to survive their pass through the atmosphere and actually land on the ground, and people are able to go and find them and collect the pieces. So congratulations in seeing a fireball. They're very rare. You should be very fortunate. Feel very fortunate. Okay. Mr. El Cupacabra. Fantasy, just fantasy. Dyson just drank a bottle of wine and other stupids took the idea for good. So this is a response to one of the videos that we did about Dyson spheres. And, you know, I get this a lot, that people sort of see this idea of a Dyson sphere and they go like, that's ridiculous. I can't imagine that such a thing will ever be built. What are people smoking to think that that's a real thing? And like, I think there's a very, very remote chance that humanity will ever actually build a Dyson sphere, that aliens actually build a Dyson sphere. The point is just that it's a thought experiment, that Dyson said, okay, we're using more energy today than we did yesterday, that our energy use is continuing to go up on an exponential curve. And exponential curves have a way of getting very big very quickly on the tail end of them. And so if you just calculate the growth of energy use by humanity over the course of the last tens of thousands of years, it is this smooth exponential curve that just goes up and up and up. And yeah, it's entirely possible that exponential curve will not continue on the same path, that it will suddenly flatten out or go back down, and suddenly we will have used up all the energy that we want to, and then we'll just use less energy because we don't want to anymore. But that's not how history has gone so far. And so how do you get more energy? And so Dyson just said, okay, how long will it take for us to use all the energy coming out of the star? And turns out it's just a couple of hundred years. If you continue our growth of energy use forward, within about 300 years or so, we will be using the equivalent of a star. Well, we happen to have a star. So then the next question that he said was, well, how would they use the energy of the star? And then he just imagined that they would enclose the star in some kind of light collecting solar panels, and they would get to this point where they were able to collect all the energy from the star. So that's literally just the beginning and the end of the idea. And it's not like a proposal. It's not like anybody's actually working on this. It's not like, you need to take it any more seriously than that. But it's a great sort of way to imagine what a futuristic advanced civilization might look like, and gives us a way to look for them out there in the universe. And so if you say, well, if an advanced civilization is using all the energy coming from a star, what would that look like? And it turns out it would be very obvious that you would see this object that kind of has the small resolution of a star, but it's only beaming out infrared radiation in a fairly specific set of wavelengths. That's very strange, not a thing that we see naturally. And so if you saw one of those things, you might say, oh, maybe that's a Dyson sphere. You could set up, and people have set up, enormous automated surveys to look at all of the stars in our vicinity. And to take it to the next idea, you're like, well, how long would it take for us to use all of the energy of a galaxy? Well, you can just follow that curve, just keep going. And really the speed of light is the drawback. But within a couple of 100,000 years, a million years tops, if we continue on this energy use, we will be using all of the energy of the entire galaxy. And that would look like something. You would see it's an object that is the size of a galaxy, but it is only glowing in the infrared spectrum. Very bizarre, and the kind of thing that would make astronomers think is interesting. So don't worry. Nobody's working on a Dyson sphere. Well, actually, I guess we are. I mean, every single satellite that we launch that uses solar panels, that is orbiting the sun, is part of the Dyson sphere. It's just, we're just building it in tiny little pieces. So I guess we have started to build the Dyson sphere. Okay. Garyunix Reborn. If we were able to build a telescope of about 150 kilometers across, would we be able to resolve large surface details on Proxima b? We've built interferometers in infrared. Could we build one strong enough to resolve Proxima b? In theory, we could absolutely build a telescope big enough to resolve features on Proxima Centauri b. We could build a telescope big enough to resolve features on the surface of a planet in the Andromeda galaxy. The bigger you make the telescope, the better the magnification, the smaller the objects that you could resolve. And so I did some quick math just before this. And so if you actually built a telescope that was 150 kilometers across, you would end up with the ability to magnify objects on the surface of Proxima Centauri b in the tens of millions, like 30 plus million times resolution. So I don't know if you would be able to see surface features to some level, but you would see a lot with a 150 kilometer telescope. You would see almost anything that you wanted to see in Proxima Centauri, and then you would be able to see less in other star systems as you went farther and farther away. So, but you mentioned this idea of building an interferometer. And an interferometer is where you essentially align two telescopes far apart. You have them sort of line up the wavelengths so that they are essentially seeing the same wavefront coming in photons coming from distant stars, distant anything. And so the way it works is that you can separate the telescopes farther and farther apart, and yet the telescopes will act like a telescope the size of their distance. And so if you take two telescopes, even just like the size of the Hubble Space Telescope, and you move them 150 kilometers apart, it will be as if you had a telescope that was 150 kilometers across. And you don't need to have all the in-between telescope. You just need the two. But you need to have them aligned perfectly down to the nanometer. Now, the other part is that what that gives you is it gives you the resolution, but it doesn't give you the ability to magnify the brightness. So essentially, you need the in-between telescope to be able to show you faint objects. And so that's why when you think about the Event Horizon telescope that was used to show the event horizon around the black hole at the heart of galaxy M87, was that they looked at a very bright object. They used a telescope the size of the Earth by having telescopes around the Earth, and they were able to see this very, very bright object that was very, very small. And that's what you can get from interferometers. But yeah, in the coming decades, we will almost certainly see space-based interferometers, visible light telescopes that are hovering in space, that are separated by some distance, that are looking at the same object, and they're acting like a telescope that is as big as the distance in between them. And they'll be great for looking at very bright objects, not great for looking at dim objects like planets. All right. Okay, so those were the pre-questions. So let's get on with the other questions. All right. VidBoy4242. Fraser, is it at all possible that the missing antimatter makes up clouds of what we call dark matter? In theory, antimatter could be dark matter, but the problem is that antimatter, when it interacts with regular matter, causes annihilation and blasts of very bright gamma radiation. And so wherever we saw, because dark matter is, whatever it is, it's 10 times the amount as regular matter, we would be seeing all of these places across the universe where the regular matter and the dark matter are interacting with each other and annihilating. And so the sky would be filled with gamma radiation from all of these blasts, and we don't see that. And so astronomers know that whatever dark matter is, it doesn't interact with regular matter in any way except for gravity. And so it can't be antimatter. Cosmic Oni, is Jupiter a failed star? No, Jupiter's not a failed star. Jupiter is made of the same stuff as the star. So Jupiter has mostly hydrogen and a quarter helium and some other elements in it left over from the Big Bang, just like the sun. So if you like, the recipe of Jupiter is very similar to the sun. Same thing with Saturn, but it's all about the mass. And so if you wanted to turn Jupiter into a star, all you would have to do is find another 77 Jupiters, mash them all together into one mega Jupiter, and then you get the smallest possible star. So Jupiter's a failed star in that it has 1/77th the mass that it needs to be able to turn into a star, which is like an abject failure. So it's a super failed star. So let's talk about Sioux origin. Oh, snap. Maybe Scott and Flower. Okay. Joshua Bingham. With increasingly high-resolution images of Andromeda, could the transit method be used on extragalactic stars? Yeah, you absolutely could use the transit method on stars in Andromeda, and actually astronomers kind of already have. So they haven't used the transit method to find planets in Andromeda yet, but they have used various methods of gravitational lensing to try to get rough estimates of how many planets there are, or at least that there are probably planets in Andromeda. And so, but when you think about the change in brightness that's required, it'll be enormous. When even like, here in the Milky Way, we can only really see out to planets that are 10,000 light years at the most. To be able to see something that is 2.5 million light years away is going to be really tough. So in the short term, it's going to be gravitational lensing. That is the technique that astronomers will use to be able to find planets in other galaxies. It's going to be a while before we can use the transit method. And the way gravitational lensing works is you get two stars that line up nicely. They line up perfectly from our perspective. And so we look out, we see a star, and a star will brighten suddenly because essentially another star has passed in front of it and acted like a natural lens. And when that star passes in front, it can have planets that are orbiting around it, and that causes weird dips in the way the gravitational lens acts, and astronomers can watch how that light curve changes and know that there are planets orbiting around that star. So that's kind of amazing how well they're able to use that technique already. Are we failed stars? Cryptolicious. Fraser, Anton Petrov reported last month-ish that astronomers reviewing old plates noticed 12 stars disappeared. I'm not exactly sure what Anton was talking about, but there is a fairly interesting piece of news that came out in the last week or so. We reported on Universe Today, and so I'm guessing it's the same story. And so for the longest time, astronomers thought that when you had the most massive stars, they would explode a supernova and collapse in their centers down to a neutron star or a black hole. And so let me do this again a bit here. Okay. So when a star like our sun reaches the end of its life, it turns up to a red giant and then puffs out all its outer layers and then shrinks back down to become a white dwarf. And so the white dwarf is the remnant that's left over after the sun goes through this process. And if you have a star that's much larger than our sun, like maybe 8 times more massive than the sun, then when it dies, it builds much more higher elements in the core. When it dies, when it reaches iron, all those outer layers collapse down inward, and you get this highly dense object called a neutron star. And you get this supernova as the material that's falling in bounces off the center of the star and goes out into space. And then astronomers thought, okay, so if we go even more massive than that, maybe 20 times the mass of the sun, 30 times the mass of the sun, then maybe in the force of this star imploding is so strong that it goes beyond turning it into a neutron star, it actually turns it into a black hole. And then same thing, all this material is piling up around the outside of this black hole. It can't feed on it quickly enough. It bounces out and you get this enormous supernova explosion. And then you're left with a black hole behind. But the new evidence seems to be that for those largest stars, they seem to just be disappearing. They're not going through this supernova black hole. And so the thinking is that maybe they just implode quietly, that there's no supernova. The star is there, and then it just folds in on itself and it turns into a black hole. And there seems to be growing evidence that for a large number of the most massive stars, they go out with a whimper, which is it's kind of terrifying when you think about this idea of just like you've got this whole star, a massive star, and then it just kind of folds up and it just disappears. And it's still there, but now it's a black hole. Lynn Linksoff. Now, when you sold your house, does this mean it's the end of the beautiful green screen Ewok Forest backgrounds era of Fraser Cain? No. Are you kidding me? Like, one of the big reasons why we bought property in the forest was to bring back the green screen era of Ewok Forest Fraser Cain. So part of the way we're building the studio, we hope, is that I should be able to set up my computer so that I'm outside, but I'm actually still working on my computer with the forest behind me. So we're going to try and figure that out so that I've got a way to be able to do that. So no, that is the plan. I understand the Ewok Forest is like part of my brand, and for me to use an actual green fake background, it's just breaking my heart. We got to get back into the forest, mosquitoes and all. That's the way the show was meant to be done. What? Back into the forest. For me. The Yellow Dart. The Large Hadron Collider could have created a black hole, but it would have been too small to be dangerous to Earth. Is it possible to build a collider big enough, equator size, to create a dangerous black hole? Right, so when physicists were creating the Large Hadron Collider, one of the worries was that as you were mashing particles with so much energy, they would be creating these dense objects that could be these microscopic black holes. And the way that, and so for a while there, this was sort of a legitimate concern. And so a bunch of scientists ran the numbers to try and figure out if this is a thing that could happen. And what they found is, well, if it did happen, the black holes would evaporate before they even hit the ground, and so it wouldn't be an issue. And the way we know that this isn't a problem is because there are cosmic rays hitting the atmosphere of the Earth with millions of times more energy than anything that is possible to do in the Large Hadron Collider, and we don't get microscopic black holes raining down on top of us all the time. And so that scales up. And so for now and into the foreseeable future, the supernova, the supermassive black holes that are generating these cosmic rays are more powerful than anything we will be able to make here on Earth. But there could be some time in the future, like we create places that are colder here on Earth than are anywhere else in the entire universe. And we create places that could be hotter, like with some of our fusion reactions, that could very well be hotter than any place in the universe. So we are actually, through our technology, starting to push the limits of things that nature has cooked up on their own. But when it comes to the energy of particles crashing together, no, we can't match what cosmic rays can do yet. But who knows? Maybe there will come this time when there is some superconducting super collider out in space, and it will be generating energies higher than nature does on its own. And that would probably be of concern. Maybe people should do some extra math when they get to that point. Cryptoman 5000. Should we go find Oumuamua? So Oumuamua, of course, was the interstellar object that passed through the solar system a couple of years ago. And then, of course, another one went by, Borisov. And so, I mean, should we go and track Oumuamua down? It is still theoretically possible if we built a really powerful rocket, say we had a Starship or we had maybe a Falcon Heavy, put a tiny little probe on top of it, launch the rocket, chase Oumuamua down for decades. You might be able to catch up with it and be able to examine it and send information back. Now that would be incredible, right? To find out what it's like, how objects formed in other star systems would be mind-blowing. It would tell us so much about the solar system. So I think, you know, if I was in charge of NASA, I would probably encourage an Oumuamua mission. But it's not in the works right now, and so I would anticipate that it's not going to happen. But that said, there are a couple of missions that are in the works to try to intercept the next extrasolar objects that come through the solar system. So the European Space Agency has a mission that they're calling DART. And so it's going to be this, essentially an interceptor for, no, it's not DART. I'll change this, Chad. All right. So the the European Space Agency is building what they're calling essentially an interstellar object interceptor. And so what it's going to be this spacecraft that loiters orbiting around the Earth, waiting for the next interstellar object to come through the solar system. And when astronomers find one that's on the right trajectory, then this small spacecraft will launch itself towards the interstellar object and do a flyby and try and catch a bunch of images of it as it passes by. That would be a great first step. That would tell us a tremendous amount about these objects. But there's a recent study from Avi Loeb and some other people about just how many interstellar objects there might be in the solar system at any one time. And according to their estimates, based on what they saw with Oumuamua and Borisov, there could be more interstellar objects in the solar system than non-interstellar objects. So when you look at the Oort cloud could actually be mostly made of interstellar objects. So, you know, we were really fortunate to be able to see Oumuamua and Borisov, but this isn't going to be the last interstellar objects that we see. We just need better detection methods, and we need to be ready. And when the next one comes along, we will chase it down and we will get that science done. Prince Charming. Do you think it's possible to detect technosignatures in the Andromeda Galaxy? It depends on the kind of technosignature that is being sent out. And of course, a technosignature is this kind of catch-all term for some way of detecting an intelligent civilization. Maybe they are sending radio signals in our direction, or maybe they're beaming light rays at us, or maybe they have built some kind of megastructure that is transiting their star and we're able to recognize that's what it is. So absolutely, I mean, we talked about this idea of a Dyson sphere at the beginning of the show. If a civilization started to enclose stars in Dyson spheres, you would see portions of Andromeda start to go dark or just be only visible in the infrared. They would stop looking like stars. It would look like there's big dark patches in visible light, but when you look in infrared light, you would see all of the stars that have been enclosed in Dyson spheres. That would be obvious. The other idea is some form of transit method, which we talked about this earlier as well. But then it would be really hard for us to detect the transit method of anything happening in Andromeda. And I mean, Andromeda's 2.5 million light years away. I mean, we have stars that are 4 light years away, 10 light years away, 100 light years away. So we've got a lot of Milky Way to explore before we really get worried and we have to start exploring Andromeda. Sorry, I'm just looking. Let's do this. Dustman, any interesting discoveries from Mars lately? Yeah, I mean, there have been a ton of really interesting science that's being done. Now, of course, if you read my newsletter, universetoday.com/newsletter, you'll see that I write every week and report on tons of interesting stuff that's happening. So I would say a lot of the interesting news that's coming on Mars has been fairly disappointing, fairly sad. There was one piece of research that we reported on that greenhouses probably aren't going to work on Mars because the cosmic rays. So the same kind of radiation that is going to give you an increased cancer risk when you're out on the surface of Mars is also going to be affecting plants that are in a greenhouse. And so if you have this dome and you've got your plants growing out on the surface of Mars and it's being blasted by radiation, it'll kill the plants. And so based on this, on the research that some scientists did, they figure greenhouses aren't going to work. Literally the only way you're going to be able to grow food on Mars is to have it underground. And like, you're going to be living underground, your plants are going to be living underground. It's starting to feel really sad. Like one of the cool features of living in your Mars city is to be in the dome, out under the beautiful Martian sky, looking at the crazy landscape. And now you don't even get to be in the greenhouse doing that anymore. So that's sad. There's some interesting ideas about where there could be liquid water on Mars. So at the North and Southern Pole, we know that there are, there's the ice caps, and the ice caps are covered in various amounts of dust. And it seems like in certain kind of conditions, the dust can warm up and cause melting in the ice underneath it that will actually collect into pockets underneath the ice. And so we need to kind of go back to the polar regions and maybe drill down to find out what could be there. Of course, there's been tons and tons that's been going on with Perseverance and the Ingenuity helicopter. I think Ingenuity is up to 12 flights at this point, and it is really it nailed it. Right? It is proven how useful a helicopter is going to be on Mars. Like, mark my words, every future spacecraft, every future rover is going to be equipped with its own helicopter. At this point now, the helicopter is making flights around Perseverance, mapping out all the terrain, finding dangerous sand that Perseverance could get stuck in, finding like interesting rock layers that Perseverance should be taking a look at. It's been just the perfect accompaniment to this rover. And in fact, apparently the Chinese are planning their own version of a of a helicopter for their future Mars rovers. The Chinese Mars rover reached its main mission. I think they're over 100 days now. So they had originally set that as their primary mission. So they've reached that, and now they're going to just keep on going because obviously the rover is still doing fine. So yeah, there's been kind of tons of news coming out of Mars. Too much for me to think about. But yeah, lots of interesting news about Mars. Let's see. Whoa. Dima R. Would there be any way to detect a war between extraterrestrials in space? That's a good question. I mean, it would be really tough. If you've watched The Expanse, they show examples of how war would work in space, and a lot of the times they have nuclear missiles, and they have essentially just kinetic impactors that they're using to fight with. But a nuclear bomb is not going to be that obvious several light years away if aliens are having some sort of war around a star. But I mean, if they got really powerful, and if things were pointed in our direction, like really powerful mega lasers, and the laser happened to be shining in our direction when it goes off, then maybe we could see something really strange. I mean, astronomers have proposed that we could look for lasers from extraterrestrial civilizations attempting to communicate with us. But if they're off in some star system having a space battle with their lasers, then maybe that's a thing that we could see. But I doubt it. Sigh. 100 million has been given to fund space-based solar power. Any comments? I don't know about that specific story, but I'm really coming around to the opinion that any attempt to utilize any resources in space to try and send it back to Earth is going to lead to failure. And I mean, when you think about solar power, for example, I mean, the cost of solar panels here on Earth is just going down and down and down. And now I think renewable energy is the cheapest form of energy there is. Solar panels are getting cheaper and cheaper. And yet if you tried to fly to space to launch your solar panels to space, it would cost you thousands of dollars per panel. So it's really hard to make that math work out. Same thing with bringing resources back. I mean, the Earth is like the biggest asteroid in the solar system. And so all of the stuff that you could find on asteroids, you can find on Earth, and you don't have to get out of the Earth's gravity well to be able to find them. So in no way will it ever be economically feasible to go to space to bring resources back to Earth. The reason you go to space to gather resources is to use them in space. And so it makes a ton of sense to collect your solar energy on the moon for your moon base, or to harvest your water on the moon for your moon base, or to harvest aluminum or iron or silicon and all those kinds of things, because that's where you're going to be using them. You're going to need them. And it's crazy to try and bring them from Earth when it's, say, hundreds of thousands of dollars a kilogram to pull material off Earth to send it to the moon. So I think a lot of the research that's going to be going into space-based resource utilization is for stuff in space, not to bring back to Earth. Miguel Angel Romero. Great to have you back. I heard that Robert Zubrin said that future Mars civilization export will be mostly knowledge because the smartest people will live there. I'll leave The Expanse. Any thoughts? Well, I think I've talked about this quite a bit. I'm not convinced that anybody is going to want to live on Mars for any long period of time. Like, like right now, Mars is the undiscovered country, the territory. It's a place of mystery. We have all these romantical notions about what it's like, and we just don't know what day-to-day existence would be like trying to live on Mars. And yeah, I've mentioned this in the past, right? The closest example is go live in Antarctica. Antarctica is a paradise compared to Mars. And so if you're living in Antarctica and you're having fun and you're really enjoying yourself and you're like, this is the best. I love the lack of vegetation, the desolate landscapes, the horrible cold, then you might be the right kind of person to go live on Mars. And so I think that for the longest time, like until we trivialize living on Mars, it's going to be a place where we send scientists, explorers, and we try to keep them alive and use all of our technology and all of our resources to try to keep them from not dying so that they can come home and tell us what they saw. That's what Mars is going to be for the longest time. I think for hundreds of years, that it's going to take us hundreds of years for our technology to grow to the point that we can fly to Mars, live on Mars. It's all going to be very easy, and it's not going to be just this desperate attempt for survival all the time. But I'd be interested to see. I know Zubrin has been really excited about Mars. Same thing with Elon Musk. Same thing with Cody, Don Reeder. So anyone who wants to go live on Mars, I sincerely hope you get a chance to go live on Mars and try out. And I also hope that there's return flights available so that if you get sick of it and you just want to come home and see oceans and trees and stuff, there's a chance for you to be able to do that as well. Use Nord. Isn't the idea of a type 1 civilization ridiculous, let alone type 2 or type 3? I mean, by the looks of it, we will never be a type 1 civilization, and we don't have any evidence for any life anywhere. So this is kind of back to the original thing. So this is a good example, right? Someone's just like dismissing the idea. Like, okay, you disagree. Oh no. Oh. My camera overheated. Yeah. So I have to let it cool down. So we're only going to get audio. Bummer. Yeah, I'm still recording. So why did the camera overheat? That's never happened before. Maybe I need to run a fan on the camera. Yeah. I'll keep the door open more. Yeah, they can still hear me. A black hole ate Fraser. Yeah, they can hear me. Nope. Yeah. Yeah. I'm still here. I'm still here. You can still hear me, right? So, yeah, you can still hear me. So the learning lesson. How old is the camera? Camera is brand new. Well, like a year old. So, all right, let me try this again. Yeah, I'm wondering about that. So I guess this is one of the engineering challenges that we're going to have to sort out. I should have invested in a YouTube and avatar. Yeah, that's a good one. Yeah. That's funny. Okay. It's okay. We've reached sort of the end of the show, so don't worry about it. I don't think we're going to put ice on put the ice pack on top of the camera. Is that your plan? Okay. I'm just going to just gonna gently put an ice pack on top of my camera. Let's see what happens. This could cause a different problem with the camera. Yeah. Yeah. Well, it is waterproof though. Yeah. But maybe in the future we'll put it in a bag or something. Okay. All right. We'll see what happens. I gotta start the recording. Oh, I guess the recording doesn't matter, but I'll start it anyway. You know what? I'm not gonna record. It was the recording that killed it. And the recording is irrelevant because this is gonna be streamed out on YouTube. Okay, I'm gonna remove the ice pack because that's freaking me out. No, not for dogs. All right. Okay. All right. I'm not going to even finish answering that question. You got the gist of it. We don't know what the future holds. It's just a thought experiment. Don't worry about it. Like, who knows what's going to happen? I'll let the dog finish drinking. That's okay. We make this invisible afterwards anyway. Okay. The Learning Asylum. Fraser, are we going to live on Venus? Well, for everything I just said about living on Mars, it's even worse for living on Venus. Like, living on the surface of Venus, it's like hot enough to melt, boron, lead. The pressure is 93 times Earth pressure. Like, you just can't live on the surface of Venus. Maybe you can live in the cloud tops, but then that would suck as well. So I think we'll be living on Venus 100 years after we live on Mars. All right, just a couple more here. Freeze the camera and dry eyes. Yeah, you have the zoom, so we have the raw video. So my plan is, because I don't have a background, we're gonna have to use the one that's coming from recorded by. Oh, I could record the Zoom. All right, I'll do that next week. I'll record the Zoom meeting to my computer, and then we'll use that for the post-production video until I'm in the new studio. Okay. Zin Famous X. Is the moon moving away? Like, is the orbit getting bigger and bigger? Yeah, the moon is getting farther away. It just like a couple of centimeters a year, but slowly over time, the moon is getting farther and farther away from us. And the reason that's happening is because the moon's gravity is interacting with the Earth's gravity, and the moon is actually slowing down the Earth's rotation. And when you sort of think about the total amount of energy that's happening in the Earth-Moon system, as the Earth's rotation slows down, in order to compensate, the moon's orbit has to shift outward. And so the moon is slowly spiraling outward at the same time that the moon is slowing down the Earth's rotation. So eventually, days will get longer and longer, and the moon will be farther and farther away. Let's see. Joshua Murphy. Does NASA have any new spacesuit designs? NASA is working on a new spacesuit design for the Artemis missions. Oh, I forget the name of it. It's like acronym, Mobile Explorer Unit or something like that. I'm sure Chad will pop up the actual name in a second here. And so essentially it's an entirely new kind of spacesuit that is different from the spacesuits that they use for doing spacewalks on the International Space Station, or the flight suits that they wear. The problem is the suits are delayed. And so it might very well be that the reason why NASA isn't going to be able to reach its goal of getting to the moon by the end of like 2024, one of the reasons is because they probably won't have the spacesuits done in time. And sort of an interesting note is that Elon Musk and SpaceX offered to build the spacesuits for them. So I guess they learned a lot with the spacesuit design that they were doing for the Crew Dragon. And because SpaceX is planning to try to land people on the moon earlier than 2024, maybe even as early as 2022, that seems really early though. But anyway, they may have been working on some kind of spacesuit design for the moon. So it might be that NASA isn't able to get their in-house spacesuit built in time, but there might be other options to be able to provide them a spacesuit. Unfortunately, all the ones that were used during the Apollo program, you can't use those anymore. So they had to sort of kind of go back to square one with that. Okay, I'm going to wrap this up. Oh, good. Okay. All right. So I got so I'm going to do the outro stuff, and then I'll stick around and answer questions and try to get through as many more of them as we can. More questions in a second, but first I'd like to thank our patrons: Sean Martz, Megan Rose, Thomas Waro, Bruce Thomas, Ray Cornelius, Jonathan Royal, and the rest of our 796 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. And then the outro. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to Universetoday. Returning from the summer hiatus, a little rough, but that's what you get when you try to shift your entire broadcast into the tiny little space in the back of a trailer. So hopefully we will make more improvements as we go along. Thanks everyone for watching, and I will see you all next week. All right. So I guess I never was recording. I'll stop that audio recording. That'll probably make the audio sound different. Okay. Oh, note to self, invite Nightbot. Okay. So here's the question. A couple of people are noting buffer. So we did this whole episode on Starlink. How did it do? Did you got a buffer just now? Did anybody see any other buffering over the course of the episode? That's kind of amazing. Wow. Huh. That's incredible. Yeah. I should take a look and see. No buffers. That was it. Okay. So is Starlink better than my gigabit internet that I had before? Wow. Let me look at the stats. So I did have a network issue for 3 seconds at 2:03 p.m. So no, that was... But maybe one happened... It looks like there was an outage for just a second. Okay. Well, there you go. Oh, okay, the outro. Bummer. All right. I'm sure I can edit around it. Or maybe it'll be fine in the rendered video. Good. Okay. All right, we'll keep an eye. Yeah, no trees, no. So the people who bought the property before us, they wiped out all of the trees in about a 5-acre chunk And it's not what we would have done. We would have preferred to kept all the trees, but they knocked out a lot of trees. And so the upside of that is that I have no problem seeing the sky from where we are. What galaxy am I in? I forget which galaxy I'm in. Yeah. Yeah, so the Starlink costs 130 Canadian dollars a month, and that's exactly what I was paying for my high-speed internet, so it's the exact same price. And so like my parents, they don't have Starlink yet, but and it looks like there's probably going to be some high-speed internet going to the island, but a bunch of the people on the island have already gotten Starlinks, and they're doing great. And so you can't, like, my parents can't get faster internet. Like, they just can't. Like, our service providers refuse to install faster internet for them. They have like 3 megabits. So, like, I've tried to broadcast shows from their house, and it just doesn't work. So, and so you can take Starlink, you can plop it down in some, there's, I mean, I'm not sure about free internet in Africa, but there have been some First Nations communities here in Canada that have been eternally neglected by the various internet service providers, and Starlink has been installed in their communities, and they're now getting high-speed access to the internet. So, and you don't need to have every single person pay. You can just literally and get that library internet, and people can go and get Wi-Fi and use it at that place. Like you can get internet in places that just it has never been. So, so I think it's a good, I've gone at length about how I feel about Starlink, that it is both good and it's terrible, and it's going to be both of those things. So. How 130 loonies. Yeah. Let's see. The image froze a couple of times, but that was okay. Okay. Jeff Robinson is saying, wow, there are a lot of cool questions not answered on here. Someone asked if we gain mass on Earth. Yes. 30 to 100 metric tons, but it isn't that much. We more than that. So is that about the mass of the Earth? Like the Earth gains a few hundred tons a year in space debris, in meteorites and things like that, but it also loses a few hundred tons a year in atmosphere being blown away by the sun. But I think, this was in my head and it's not in my head anymore, exactly what those numbers are, but I think we are losing mass faster than we're gaining it. Anyway. All right, let me see if there's any. Let me hit some quick questions here. I'm on Vancouver Island, not Vancouver. Are we going to send, so let's see, Dr. Ed Elcott, are we going to send a probe to that massive comet in 10 years? There are no plans that I know of to send any probes to any comets. So, no. Cryptolicious, Fraser, we should make an NFT of you and your gravity wells for suckers and others, a collection? No. Again, until I can be convinced that NFTs are not a scam. I've talked this a bit before. Like, I'm okay. The idea of NFTs, which are like a pass that gets you into special events that we do, I'm cool with that. But to just like mark a piece of art and say that it's worth money, I'm not really into it. And I've done a lot of research in NFTs, so I understand how they work and what they are, but without the uniqueness of some other value and benefit on top of it, it doesn't really fly for me. So I would love to come up with some cool connection with the Discord server and have some sort of, club that we sell an NFT, and you do get a copy of some piece of artwork, and then you can sell that to someone else, and then maybe the astrophotographer who took the picture gets a share in the money, but also the NFT acts like your key to be able to get into various special events that we do. That would be really cool, but then I would need to talk to astrophotographers and come up with special events and so on. So it's kind of in my head, but Arjone, is there a way to predict holes in the coverage so you can work around it? You're talking about Starlink? Like at this point, there's no holes in the coverage. Like Starlink is just on all the time and it works. So it was pretty rough a year ago when we first got it, but it's good now. Larry Beckham, any news on the mile-wide Chinese space station? Man, I don't know. People have been reporting on this, and we reported on it on Universe Today. So I'm not going to call out anybody for irresponsible reporting because clicks. But we need more details. Like, are they planning on building something? Like the International Space Station is, say, 100 meters across. So they're looking at something that would be 10 times, 20 times bigger than the ISS. If you thought about like 3D printed trusses in space, then you could build very large structures reasonably inexpensively. We've talked about you could send like one barrel of material up into space and you would be able to build a space telescope that's 100 meters across. So there's a lot of cool ideas. So maybe that's what they're getting at. I don't really know any of the details yet. Kind of sounds like wishful thinking right now. But hey, I can't wait to be proven wrong. All right. Let's see one more, and then why don't I trust a blimp colony? Tomfoolery. What are the chances that dark matter is actually a misunderstanding of gravity and its effects on local space-time and not an undiscovered particle? Fairly low at this point. The two main ideas for dark matter is that it is a particle or it is a misunderstanding of the way gravity works at the largest scales. So they call it modified Newtonian dynamics, MOND. And the evidence is now overwhelming that it is a particle. There's so many independent lines of evidence that say this thing is probably a particle. We don't know what particle it is. We haven't been able to find it, etc. But it is, if we didn't understand gravity in a certain way, we would see the universe behaving in a certain way. But astronomers at this point are able to map out the amount of dark matter with incredible resolution. They see galaxies with too much dark matter, galaxies with not enough dark matter, galaxies that are only dark matter, galaxies that have no dark matter. So they've mapped out the dark matter so well that the chances that it's gravity working in a way we don't understand is very small. But you'll still see proponents who hold on to that idea, and if they can produce the evidence that shows that it really is that, then more power to them. I mean, that's how science works. All right, I am going to now officially wrap things up. So thank you, everybody, for hanging out. That was a lot of fun. We will be, like I said, doing an interview on Wednesday about building a star shade for ground telescopes. And then next week, we're going to be talking about the cosmic dawn and everything that happens then. So lots of cool interviews coming up. And of course, we'll do another one of these episodes next week. And later on this month or into early October, the weekly Space Hangout returns, Astronomy Cast returns, and then we should just be back in full operation again, recording everything from my trailer studio. All right. Thanks, everybody. And we'll see you all next week.